Hello Year 7. Today I am going to read through the assessment. If you do not need a reader and you're happy just to do the assessment by yourself, then you don't need to watch this video, just crack on with the test. If you would like a reader, then listen in, and if I'm going too fast, which I will because I won't give you time to answer, just pause the video, answer the question, and then resume the video when you're ready to go on to the next question. So, question 1A. The drawings below show 3 objects made from copper. Draw a line from each object to the reason for using copper for that object. Draw only 3 lines. So you've got a base of a saucepan, you've got a coin, and you've got wires and a cable. What is the reason for using copper? Is it does not rust? It is a good conductor of electricity? It is a good conductor of heat? Or it is not magnetic? Okay. Part B. Brass is a mixture of copper and zinc. Some keys are made from brass. Why is brass more suitable than copper for a key? Tick 2 correct boxes. Is it? Brass does not bend as easily as copper. Brass is harder than copper. Brass is not such a good conductor of electricity as copper. Brass is paler colour than copper. Brass is not as shiny as copper. Or brass is not such a good conductor of heat as copper. Part C. Zinc melts at 420 degrees centigrade. Copper melts at 1085 degrees centigrade. Scientists heated a mixture of pieces of copper to 600 degrees in a dish. Sorry, I'll read that again. A scientist heated a mixture of pieces of zinc and pieces of copper to 600 degrees in a dish. What would be in the dish at 600 degrees? Is it liquid zinc and liquid copper, liquid zinc and solid copper, solid zinc and liquid copper, or solid zinc and solid copper? Question 2. The list below shows properties that different elements can have. Here are the properties: magnetic, can be compressed, very high melting point, very low melting point, good conductor of heat, poor conductor of heat, good conductor of electricity, and poor conductor of electricity. Which 2 properties from the list above make aluminium suitable for saucepans? Part B. Which property in the list above explains why copper is used in the cable of a television? And part 2. A lot of oxygen gas can be pumped into a very small container. Question 3. Part A. The table below shows information about 5 elements. So, element A has a melting point of -7 degrees centigrade, has a boiling point of 59 degrees centigrade, does not conduct electricity, and is brown. Element B is -218 degrees centigrade melting point, has a boiling point of -183, does not conduct electricity, and is colourless. You can see the same information for C, its melting point, its boiling point, if it conducts electricity or not, and its colour, and for D and E. Part 1. Which 2 of these elements are likely to be metals? Write the letters. Part 2. Which element in the table is a liquid at room temperature? Write the letter. Part B. What is the chemical symbol for copper? Tick the correct box. Part C. How many atoms of iron and oxygen are there shown in the formulas for FeO, which is iron oxide, and Fe2O3, which is another type of iron oxide? Complete the table below. So you've got the compound, FeO, number of atoms of iron and number of atoms of oxygen, Fe2O3, number of atoms of iron and number of atoms of oxygen. Question 4. Samantha opened a tin of white paint. The paint consisted of a liquid and particles of titanium oxide that are insoluble in the liquid. The paint had separated into 2 layers as shown below. Here is the liquid on the top and the particles of insoluble titanium dioxide on the bottom. What type of substance is the paint? Tick the correct box. Is it a compound, an element, or a mixture? Part 2. What type of substance is titanium dioxide? Is it a compound, an element, or a mixture? Part 3. Why did the particles of insoluble titanium dioxide sink to the bottom? B. Samantha stirred the paint and used it to paint a window frame. She got some of the paint on the glass. Samantha could not get the paint off the glass with water. When she used a different liquid called white spirit, the paint came off. Why could she remove the paint with white spirit but not water? Question 5. A teacher mixed iron filings with sulfur on a metal tray. She heated the mixture in a fume cupboard. Sulfur is yellow. Iron filings are grey. So here is the mixture of iron filings and sulfur just before it gets heated. The mixture glowed very brightly. The teacher turned off the Bunsen burner. The glow spread through the mixture. When the mixture cooled, a black solid called iron sulfide was left. From this information, give one way you can tell that a chemical reaction took place. Part B. What type of substance is each of the chemicals involved in this reaction? Choose from: metallic element, mixture, non-metallic element, compound. So, what type of substance is iron? What type of substance is sulfur? And what type of substance is iron sulfide? So, part C. Raj held a magnet near the end of 3 chemicals. By each chemical in the table, write yes or no to show if the chemical was magnetic. One has been done for you. So, was it magnetic? Well, iron sulfide was no. Is sulfur magnetic? Yes or no. Is iron magnetic? Yes or no. Part D. 1. When iron is heated with sulfur, iron sulfide is formed. Give the name of the solid formed when zinc is heated with sulfur. Part 2. Some fossil fuels contain sulfur. When fuels burn, sulfur reacts with oxygen. Complete the word equation for this reaction. Sulfur plus oxygen makes blank. Question 6. 6 groups of pupils burned magnesium in air. The magnesium reacted with oxygen to form magnesium oxide. They recorded the mass of magnesium used and the mass of magnesium oxide formed. Their results are shown in the table. So, here's the different group, A, B, C, D, E, and F. Their mass of magnesium that they burned, and the mass of magnesium oxide that was formed. Now, if you are struggling with this question, you can leave this out because unless you print the paper out, it's going to be very hard to do. So I would probably leave this one out if you are working on a computer. So it's saying that you need to plot the mass of magnesium against the mass of magnesium oxide. If you can print it out, you need to do these four things. Decide on a scale, plot the points, label the axes, draw the line of best fit. At the very least, you can draw a text box and label the axes correctly. That'll get you a mark. So part B, which group's results do not fit the pattern? Part 2, how should the class deal with this odd result? C, use the graph to predict the mass of magnesium oxide that will be formed by burning 7 grams of magnesium. And part D, the results show the relationship between the mass of magnesium and the mass of magnesium oxide formed. What conclusion could you draw about this relationship? Right, question 7. The apparatus shown below was set up. The 100 centimeter cubed of clean, dry air was passed backwards and forwards across a hot copper powder. The volume of air left in the syringe when the apparatus had cooled back to room temperature was 79 centimeters cubed. So here is the diagram of the experiment. So you've got some connectors to make sure that no gas can escape. You've got some glass wool to make sure the copper stays in the middle here. And you've got heat. Then you've got a syringe that originally had 100 centimeters cubed of dry air at room temperature that they pushed through to this syringe, then they pushed back, and they kept doing that until the reaction was complete. So, part A1. Why did the volume of air decrease? Part 2. Why did the volume of air not decrease below 79 centimeters cubed? Part B1. The surface of the copper was seen to be black at the end of the experiment. What is the chemical formula of the black solid which is formed? Part 2. What type of reaction takes place in this experiment? Part 3. Write a balanced equation for the formation of the black solid. Question 8. John Dalton wrote these statements in 1808. All substances are made of a vast number of extremely small particles called atoms. Every particle of water is like every other particle of water. Every particle of hydrogen is like every other particle of hydrogen, etc. Part A. Every particle of water is like every other particle of water. Use Dalton's ideas and your knowledge of water to explain why. Part B. Dalton thought that all atoms of an element were exactly the same. We now know that it is possible to have atoms of the same element but with different mass numbers. The diagrams represent two atoms of hydrogen, atom A of hydrogen and atom B of hydrogen. State in terms of particles how these two atoms are different. Question 9. There are millions of different substances that make up our world. All these substances are made from chemical elements. What is an element? Part B. Many substances are compounds. What is a compound? And that is the last question. So please fill that in and email it in to me.